Good morning, everybody. I hope everybody had a fantastic weekend. Looking forward to teaching you this lesson today. We're starting a brand new chapter today. It's all about functions, which is good for some of you because it's completely different than what we've been talking about previous to today. So many of you will probably find that very enjoyable. But we're going to start with lesson 8.1, so you can open your ebooks up to page 332. Obviously, I'm recording this for you guys, so you can always get the link from your teacher to view it at any point. Also, you can search for me on YouTube, my YouTube channel. I'll have this uploaded there too, so you can always go back and review it just in case you got some questions when you're working on your homework tonight. So the title of the lesson is Functional Operations. Now, we already are familiar with a function. We know it's just another way to write a particular concept when it comes to an equation. We've dealt with lines before, y equals mx plus b, that type of thing. And you can always substitute the value f of x for y. And that's what's done here in this particular equation. You guys see this here. They simply say f of x. And they say f of x instead of saying y equals. But literally all you have to do here is it's a basic substitution problem. You're literally taking 2 and you're plugging it in the place of x. So if you look at the equation here, you have a value of x here that's being squared. So I put 2 in that parentheses, plus 5 parentheses for the x, and in the parentheses I put 2. And then I say minus 7. And you calculate all that, and you end up getting a value of 7. So f of 2 in this particular equation is equal to 7. Now look at the next example. This is kind of interesting. You have f of 0, so I'm plugging 0 in the place of x. So that would literally give me 1 over 0. Well, probably you guys understand this. That's a problem because it violates one of our rules. We cannot divide by 0. So this is an example of a function that's undefined. It's impossible to solve for it. And then looking at this last example, you guys could probably figure this out. Instead of saying x, we're going to say this 6. So I'm going to say the square root of, instead of saying x, put a parentheses and put 6 inside of it. And then say minus 11. You calculate that and you get 5. So that's really what we're focusing on today, except we're going to look at a couple of different properties. If you look on page 332, you'll see what I'm talking about. You'll see function operations. Okay, you got that little box there again on page 332. There's the addition function. Now, this looks really hard, but I promise it's not very difficult. Literally, this is saying if you say f plus g of x, you can split the functions apart and say that's f of x plus g of x. All this will make sense once we start working some example problems. I promise it will. Then the next one is a subtraction. So literally you're taking the f function and the g function and you're subtracting the values of the two. You have a multiplication, fg of x, where that is f of x times g of x. So whatever the f of x function is, you multiply it times the g of x function, excuse me, and you end up getting the fg of x function. There is a division, f divided by g of x. That's equal to the f of x function divided by the g of x function. But g of x cannot equal 0 because that would give us a function that's undefined. So this function operation chart here is what we're going to be working with today. Again, it's not super difficult. I think you'll find this pretty interesting and probably pretty easy at some points. Now, the domain of the resulting function is the intersection of the domains of the two functions. So if it ever asks you for what's the domain of the function, it's basically taking the domain of the first function, f of x function, and the domain of the g of x function, and wherever they're going to intersect or overlap is going to be the domain of that particular function. The domain of the resulting function may also be limited by the fact that the division by 0 is undefined. So if in your function you combine it and you try to figure out what it is, the domain on that function, if it's divided by 0, may make that undefined, so you have to state that in the domain. It sounds really hard, but I promise it's not super difficult because you literally are finding like f plus g of x. You're finding what f plus g of x is, and then whatever that final piece is, that's actually going to be the domain. So that's how that works. Okay, so this is what it actually is talking about. They call this a function machine just to kind of illustrate it. You have f of x. In this case, this follows the f of x plus the g of x piece, which is literally going to be written as f plus g of x. So I'm just adding the two functions together. Here you see what the f of x function is. Here you see what the g of function is. So literally you're just adding them together. And what the text does is they figure it out separately, which is perfectly fine. They take 4 and they plug it in the value. So you would say 4 plus 1, that quantity squared. We all can do that in your head. 4 plus 1 is 5. You square that and you end up getting 25. Then they take 4 and they plug it into the g of x function. Take 4 and they literally substitute it in the place of x. So they say 4 minus 2, which would give us 2. So the f plus g of x function would be 25 plus 2, which is equal to 27. So that kind of just gives you a visual image of what actually takes place here. All right, so let's take a look here at a couple more statements, and then we'll move on here. An operation with two functions can be written as a single equivalent function, and that's kind of what we're talking about here, f plus g of x. So here's example 1a. You see it there at the bottom of the text there. We know f of x is equal to x squared, x plus 1, the quantity squared. And we know g of x is equal to x minus 2. This problem asks us to evaluate f plus g of x. So that, according to the function operation chart you guys see and hopefully have written down by now, that literally means f of x plus g of x. So whatever the f of x function is, you simply add it to the g of x function. You guys can see here that's the f of x function, which is where they put right there. And then this is the g of x function, which is what they put there. So literally you've got to square that out because we got to simplify this. So you can FOIL it out by saying x plus 1 times x plus 1, or you can use the shortcut method that I've taught you a couple times now, square the first of the product, square the last. Either way, when you square the quantity x plus 1, you're going to get x squared plus 2x plus 1. And then I just copy down here the x minus 2. And then this, guys, it's as easy as simplifying it. Just add your like terms, and you simplify it, and you get your answer. And what this means is f plus g of x is actually equal to x squared plus 3x minus 1. So literally, you're just taking the f of x function and adding it to the g of x function. Here, I changed it up. We're subtracting now. F minus g of x. So, according to the chart, and properly, hopefully, maybe even have it memorized right now, that means f of x minus g of x. So you take the f of x function, which again is right here, and then you subtract from that the g of x function, which is right there. So written out, you write it out like you normally would, guys. You just write the f of x function minus the g of x. Again, this is f of x right here, and this is g of x right there. So I subtract them. Go ahead and square out that first one, just like it was in the last problem. Now be careful here on this last part. You do have to use distributive property. Don't miss that. So you get x squared plus x plus 3 is once you simplify everything. So that's basically how it works, guys. It's just simplification. Here, same example, just fg of x. This means we multiply the two functions. So we say f of x times g of x. So again, you write everything out just like we had previously, x plus 1 the quantity squared, but this time we're going to multiply it times x minus 2. So again, you square that out, and then you multiply this out. Again, you'll have to use distributive property here. Some students distribute it this way, which is perfectly fine. And then they go to the next term and multiply that out. If that's how you want to do it, and then finish with the last term, that's perfectly fine as well. Some students actually prefer to do this and solve this backwards. They'll draw the arrows this direction, which again is perfectly fine. You can do it either way. But some students prefer this because you end up just doing it twice instead of 3 times on each term. So either way, you end up with the proper answer if you multiply properly. Add your like terms up, and you get x cubed minus 3x minus 2. Finally, we have the division component. You literally take the f of x function and divide it by the g of x function. So go ahead and multiply this out. This basically is simplified. You can't simplify it because you can't cancel anything out. But notice you do have to include your domain where x does not equal 2, because if x equaled 2, it would give you a value of 0 in your denominator. That would be 2 minus 2, which would give us 0, which we know would be undefined. So that's all you have to do. This is what it actually looks like if you graph it. You guys are not going to have to graph these. It's just showing you how they interact with each other and how it gives you the particular values if you multiply, divide, add, or subtract these graphs, well, the functions technically, once you graph them out. Again, you guys aren't going to have to be, I'm not going to require you to do this. It just kind of shows you how it all fits together. Okay. Moving right along here. Hopefully that was pretty straightforward. I hope it was. We'll try to do a couple of example problems at the end of the video to try to help you guys understand it a little bit more. The next concept is called a composition function. Now the composition function is a little bit more difficult, but don't get freaked out about it. It's not too bad. The composition function of two functions is denoted f with a raised dot of g, and this is read f of g of x. Sometimes textbooks will rewrite it like you guys see here, f of g of x. And literally what this means is you're taking a function and plugging it into a function. Sounds kind of weird, I know, but again, once I show you how it works, it's really not too bad. Again, it's literally taking a function and substituting it into a function. Here's an expression expressing f of g of x as f of g of x. Again, these two pieces are the same. It could be written either way. Most textbooks will write it this way, all right, but it could be written either way. It's just a helpful way of evaluating a given value of x. First evaluate the inner function, the g of x, and then use the resulting value to evaluate the f of x function. So let me show you how this works. I know I've gone through this quickly. I really just need to show you how it works, and it probably will make a little bit more sense. Okay, so if you're looking at this example, it says f of x is x squared minus 3, and g of x is 2x plus 1. And the problem says evaluate f of g of negative 2. Now, you can do this two ways. You can solve for g of x by plugging in negative 2 in the place of x, and then take that value and plug it in the f of x value. Or you can just, at the very beginning, plug in the g of x function into the f of x function and substitute the negative 2 in. That's typically how I do it. Literally this means is you take this value for g of x, and you take that value and you plug it into the value for x in the f of x function. So literally you're taking the g of x function and plugging it into the f of x function, and you plug it into where it says x squared. So again, literally you take the value of g of x and you plug it into the f of x function where it says x. So if I did that, I have f of x is equal to the quantity x squared. But remember, I'm taking the actual g of x value and plugging it into that parentheses. Just like on the previous ones, we took a number and plugged it into the unknown or the variable. Here I'm actually taking an entire function and plugging it into the variable. And then the f of x function says x squared, which is what this stands for now, and then minus the 3. Because it says minus 3. Okay, so now here, guys, you just square this out. Again, I'm going to use my fast method. I square the first term, square 2x, you get 4x squared. Double the product of 2x and 1 is 2x, so double that, you get 4x. And then square the last term, which is 1, and square that, I get plus 1. And then I say minus 3. So that's what that function is equal to. Now you can simplify this even more and say 4x squared plus 4x, 1 minus 3 is minus 2. Now, since you've done that, now you can evaluate the x value. So instead of saying x, I'm going to substitute the negative 2 in. So 4 times negative 2 squared plus 4 times negative 2 minus 2. You simplify that, then you get your answer. All right, so I know that's a lot of material up here. So let's see what happens. You guys can see the steps here once again. Now, they choose to do something different, and you can do this. Some students find this easier. To be honest with you, it is a little bit easier. The other way is the more advanced way, and it's actually the way I prefer just because that's the way I was taught. However, this is probably a little bit of an easier way. What the textbook recommends is to go ahead and solve. Go ahead and plug the negative 2 in for the g of x. So you take the g of x function right here, and literally I plug that 2 in the place of x. And you can see that's what's done here. 2 times x, which was negative 2, plus 1 gives you negative 3. And then they'll take that value and they'll plug it into the f of x. So they'll take this -3 and they substitute it back in where you see x in the f of x function. So that would be -3, the quantity squared, minus 3, which would give us 9 minus 3, which sure enough does equal 6. So the composition functions seem a little bit more difficult, and to be honest, they are a little bit more challenging, but that's how it works. You're simply substituting an entire function into another function. A composition function can be written as a single equivalent function. Usually f of g of x does not equal g of f of x, so they're not going to be vice versa. You can't, usually that doesn't take place. Okay, so here's an example. Example 3a. If f of x is x squared minus 3 and g of x is equal to 2x plus 1, write a single function rule for f of g of x. Literally what this is trying to get us to do is just plug this value in for x. Again, f of g means you take the g value and you plug it in the value of f. So they rewrote it like this, and that's perfectly acceptable. So literally, I'm taking this value here and plugging it into x here, and also, which means I'm going to end up plugging it in there. So you can see that's what they do. They know g of x is 2x plus 1. So they take that value and they substitute it in the place of this. That's where they get the 2x plus 1, and they are squaring x. So they say that squared minus 3. And then it's just a matter of simplification. Once again, guys, just square it out. Square those terms out. And again, I do the fast method, square the first up product, square the last. But for those of you that don't like that method, you can just literally FOIL it out on the side. And when you FOIL it out, you'll end up with this quantity right here. So don't get confused about that. It's just a faster way to do it. So you're not solving for anything because it didn't say it was any value. Now notice this though, guys. This, it switches it around. Instead of saying f of g of x, it says g of f of x. So hopefully, if you remember this, this simply means I take the f function and plug it into the g of x function. So here's the f function, x squared minus 3. So I'm going to substitute that value in the g function where it says x. You always take the second one and plug it into the first one. That's the rule, okay? So they rewrite it as g of f of x is equal to g of f of x. It's the same thing. So they literally take the value of f of x, which was right here, and they plug it in the place of x. Well, when you do that, you plug it in here, which will give us 2 times the value of x, which is x squared minus 3 plus 1. Simplify that, and your single function rule is 2x squared minus 5. Okay, so it can get a little bit more difficult. Here's one that's a little bit more challenging. It's f of g of x, which hopefully you guys understand now. I take the value of g and plug it into the value of f. So you guys can see that g of x is the square root of x minus 3. Now don't let that freak you out. Once you substitute it in, you'll see it actually simplifies pretty nicely. So I literally take that value for g of x and I plug it into where I have x in the f of x function. Again, f of g of x, a composition function, you take the second function, the g function in this case, and substitute it into the f function. So that would equal 1 over the quantity, the square root of x minus 3, and that quantity is being squared because it says x squared. So this one's easy, right? Because it just simplifies, and you get 1 over x minus 3 for your function. And you can see here, that's what happens. They end up getting this particular piece, they substitute the value in, and they square it out, and they get the 1 over x minus 3. Do keep in mind, though, you have to state your domain for this particular problem. The domain of the g function, or the f of g function, either ways, or you could just simply put the domain, that would be acceptable. X has to be greater than or equal to 3, because if you look at this piece right here, the domain on the g function, x cannot be less than 3. Because 3 minus 3, if you say 3 minus 3, you guys know you get 0, and the square root of 0 is 0. But if I put like a negative, or if I put a 2 in there, that would be 2 minus 3, which would give me -1, which we cannot have an imaginary number in this particular concept. So you have to state the domain of the g function. And then finally, in the f of g of f function, this x here cannot be 3 because that would give us a denominator of 0. So when you put it together, you have to basically fuse the two together. You said in the domain of the g of function, this function here, x had to be greater than or equal to 3. In the f of x function, we know this piece, x cannot be 3. So that's going to remove the equal to sign because it can't be equal to. Remember, it's a combination of both of them. So this would be my final domain for this particular problem. These are just going to take a little bit of time to get to practice these. It's not extremely difficult, but it is kind of challenging, and you just got to be careful. All right, so let's talk about your assignment. I want you guys to do numbers 2 through 30, the even problems. Again, 2 through 30, the even problems. So what I'm going to do right now, I got a little bit of time left. I want to go over one of these with you, okay? So I'm going to do number 2. So flip over to page 335, look at number 2. Number 2 simply says we need to evaluate f minus g of x. But if you look at the instructions, and you see that f of x is equal to 3x minus 4, and g of x is equal to x plus 1. Now, if you're looking at the page on 335 on exercise A, you'll notice that the instructions, it also includes an h of x, but I don't need that here because I'm simply dealing with f and g. Okay? So here, guys, not too bad. I'm subtracting these two functions. So literally, this could be rewritten if you wanted to think of it this way. It's the f of x function minus the g of x function. So literally, all I have to do is put the value in. The f of x function is right there. It's 3x minus 4. And then I put a negative sign. That's this negative sign. I need to put a parenthesis here because that's going to be the g of x function, which is x plus 1. So guys, simplifying this hopefully isn't too bad from here. I'm going to say 3x minus 4. I need to use distributive property here. So that would give me negative x and then minus 1. And then guys, it's as simple as simplifying this. You have like terms here. That's 3x minus x, which would give me 2x. And then I have negative 4 minus 1, which is going to give me negative 5. And 2x minus 5, will be your answer for this particular problem. Again, it's not too bad, not super difficult, but you're just going to have to think through that. I'm not going to take the time to look at the section on page 336, numbers 13 through 18, but what you need to do is look at example 4 in the notes, in the lesson I should say, in order to be successful with that problem. Kind of tricky, but I think you'll be okay. And, well, I'll tell you what, in fact, I'm going to do one for you. Make sure you guys understand because it is a little bit tricky. All right, I'm going to do number 13. You guys don't have to do that. But 13 says f of g of x, but instead of x, it actually gives us a number of 1. What this means is, if you guys look in the textbook, you have f, the f function has the domain of -2 and -1. It has 0 and 1, and then it has 1 and 2, and one more, 2 and 3. That's the domain on the f function. The g function's domain is 0 and 4, 1 and 2, 2 and 0, and 3 and -2. Okay, again, this looks kind of difficult, but it's really not as hard as you may think. Basically, what you have to do is you have to look at the g function first, because f of g literally means I'm taking the g function and plugging it into the f function. Now, there's no expressions here, nothing given, so it's not going to be that hard. Literally, what you have to do is you have to look at the g function first, and I'm trying to find the value for x, because remember, usually it says f of g of x. I'm looking for the value of x where it's equal to 1. And you guys can see right here, x is equal to 1. Notice when I evaluate that, the y on that is going to be 2. So what you have to do here is, since you're taking the value of 1, the x value is 1. When x is 1, y is basically 2. So that's the value that you're going to be plugging into the f function. So literally all you have to do here is, I'm looking for the 1, the x in the g function of 1, and I notice that's the number 2. Then you look up at the f function, and you try to find the number 2 for the x term. Well, this is negative 2, so that's not it. This is 0, so that's not it. This is 1, so that's not it. Well, here you go. That's where the 2 is. So the question is, what y, or f of x in this case, corresponds with x being 2? Well, it's 3. So the actual answer for number 13 is 3. Again, let me go over that again. I can't erase all these circles and things I have on the screen, so I have to change the color. What if it said, we'll do 14. Look at 14. It changes the 1 to a 3. So look at the g of x function first. Find 3. Well, here it is, right there. So when x is 3, the function is equal to negative 2. But now I'm going to the f function, the f of x function, and I'm looking for negative 2. Well, here it is, negative 2. So when that is negative 2, your f of function is going to be equal to negative 1. So our answer for number 14 is negative 1. It's just a matter of finding 1, finding 1x in a function, finding what its y is equal to, and then finding that y in the x coordinate, if you want to think about it like that, in the f of x function in this case, and then just seeing what its y is equal to. That's all you have to do here. I know it's a little bit tricky, but I think you guys can handle it from there. So guys, that's it. That's your assignment today. Hope you'll have a fantastic day and work hard. I think you can do well on this lesson, and I'll have the lesson prepared, next lesson prepared for you to watch tomorrow. Have an awesome day, guys. Bye-bye.